an individual team has several service binaries, actually in this case many service binaries, that are available for their reasoning system to try to find a vulnerability in and potentially roll out patches, defend their system. And each one of these little hex tiles represents one of those challenge binaries or one of those services. So in this instance we can see an example of an individual challenge that is running normally. It has the size that would indicate that it's been available, and it also has a white border around it, which we can see means that it has not had a vulnerability proven against it successfully. So this basically means that no one else has scored against them using one of the proof of vulnerabilities to show that they're still running a vulnerable version. In this instance, we can see that this particular piece of software is still running successfully, still protected, but it also has a network IDS rule in place. So the teams actually have, the bots are actually able to roll out IDS rules to filter traffic directly to any of the individual challenge binaries. And when they do, that's annotated via this sort of little contact lens looking. And additionally, we see that some of these services have this little black gearbox going on. And what the black gearbox means is that the team is currently in the process of rolling out a patch to their binary. So the bots themselves, when they find these vulnerabilities, they're capable of writing patches to the software that hopefully implement security for that particular vulnerable condition, right? When the team does that, or when the bot does that, that service can get rolled out into the game environment. And as it does, for that round, they incur 1 round of downtime for that service, just like in real life. So all of this is being modeled sort of around the idea of running an enterprise environment where you have multiple services running on many machines. Additionally, we can see this little blue gearbox that's formed on several of these, and that's actually when that individual service is down for an update to the IDS rules. So the IDS rules, like we were talking about in the little contact lens image, those also require an update deployment that requires them to be down for 1 round. Throughout this whole card, you can basically see the service status of every team's service and each of the services. Moving on, we can see inbound network traffic coming from this, which represents the scoring system at this point. The scoring system is responsible for ensuring that every single one of those services is working correctly and doing what it's supposed to be doing. So that being the case, the service polls, every little one of these dots actually represents a real service poll occurring in the system. And every one of these little arrows with the cone on the front represents an individual proof of vulnerability being attempted by another team. So this is another team attempting to prove that they are still running a vulnerable service. And each one of these, as these are traveling along, every element of this view is data-driven. Every one of these is programmatically generated directly from the actual data coming off of the scoring engine. So each of these service polls, as they fly along, will reach the intended service hex, as you can see, and we'll see also the proof of vulnerability little arrows. They reach the service hexes, and basically each one of them, when successfully proven, it shows with the color of which team proved that vulnerability, and the individual service polls will actually turn red or green as they approach the service tile to show whether or not they're passing functionality tests. So besides needing to be available from a performance perspective, the service also, of course, has to do what it was intended to do, right? A mail server has to continue being a mail server. And so that being the case, the green ones are instances where that modification or that service poll is passing functionality. And in instances where it's not passing functionality, they turn red. If the POV is thrown unsuccessfully, you'll just see the line come through and hit the service, but the service is not affected by it.